Alta Jama Productions presents
Hey there! You must be so smart. Can you answer my question?
Of course I can. What's your name, little ducky?
Curioso Doña Pato. My question is, I saw an arc of many colors and the sun was out.
Oh, well, you saw a rainbow.
Oh, so that's what it was. What is it?
Well, a rainbow is when sunlight goes through raindrops. I work on a rainbow project. You want me to show you?
Okay.
I work on primarily just one project. The project is called Tesis. It stands for the Total and Spectral Irradiance Monitor. And it's a satellite that we are building here at LASP. It will be launched sometime in 2016 or 2015. So I work primarily on one instrument called SIM, the Spectral Irradiance Monitor. And it's an instrument that's going to be looking at the sun and monitoring how much energy is coming from the sun at each individual color. And that's primarily what I work on.
Wait, I have one more question.
Yeah, what is it?
Why do you have snakes coming out of your hair?
Oh, well, that's because it's Halloween.
I wish I had a costume.
You know what? I have an extra one. You want it?
Yeah, yay!
All right, let's go. So that we can keep the instruments clean and keep them from getting shocked. Let me show you one of my instruments. This is TIM. It's part of an instrument suite called Tesis, which is the Total and Spectral Irradiance Monitor. TIM looks at the sun and sees how much energy the sun is putting out. So this is the lab I work in. I'll show you. So our instrument is right here in that tank. It's a vacuum chamber, and we like to put it in the vacuum because, well, it's going to go launch into space, and space is a vacuum too. And so we like to test it like it's going to be in orbit, and it also helps keep it clean and keeps it safe from anybody walking around who might accidentally touch it. So watch your eyes, this can be really bright, but what we have right here is a laser, and this laser is really, really bright, and we can actually take this laser, see it's green right now, and we can change its color to any color of the rainbow. And that way, since our instrument is studying rainbows and needs to be able to see every color, we can change the color of light that we shine into it and understand how our instrument reacts to different colors, like green and orange and blue.
How many colors are there?
Oh, there are a lot of colors. So there's your red, orange, yellow, green, blue, and purple. And each one of those colors has different shades. And you also have infrared and ultraviolet.
Is there any rainbows in space?
Well, that's a good question. So if you remember, the rainbow was caused from sunlight going through a water drop. In space, there's no water, there's no rain, but our instrument has something called a prism, and a prism acts like a raindrop. So the sunlight comes in, and then it outputs a rainbow.
Oh, that's cool.
Yeah.
What do you use the mirrors for?
Well, we use all these mirrors to steer the light around. So you see the light first comes in this way, and then we bounce it through here, and then we bounce it here, and we bounce it there, and eventually we put it through a bunch of mirrors that goes into our vacuum chamber here, which is where the instrument is. So we just use the mirrors to steer the light around so it can go into the instrument.
What do you need all this data for?
Oh, well, so we use this computer in order to monitor our instrument. So if we want to let's say we could move the instrument a little bit, then we use this computer in order to do that. We also use this computer to see, we shine light into the instrument and we want to see what the instrument, how it reacts, and that's what we have plotted up here. So here we have no laser light coming, and then the laser gets through, and then it goes away again. Let me show you some of the other labs I work in. This room is called the black room, and you'll see why in a second.
Why is this room all black?
Well, let me show you. So all the walls and ceilings and tiles are painted black so that we can get rid of all of the light in the lab. So if we have some detector or instrument that's really, really sensitive to even the tiniest amount of light, we can get rid of all of the extra light sources.
So what do you do in here?
Well, we would take maybe one of our detectors and bolt it down onto a table like this, and then we'd maybe get a laser or a flashlight and shine only that light onto our detector so that we can understand how it works. This is my office. Here's my whiteboard.
What is all that math for?
Well, it's just to help me understand what's going on and help me think through a bunch of stuff.
Hey, I just met you. This math is crazy, but I could learn it, so adopt me maybe.
Sure, I'd love to. We could go trick-or-treating tonight.
Oh, that would be fun.
All right, well, let's go.